Hi, I'm Brooklyn, and this is my Physics 2211 Lab for Oscillations. In order to do this lab, we first need to understand the fundamental physics principles behind it. This includes the momentum principle, or Newton's second law. The force of an object is equal to the change in its momentum, and this can be rearranged to solve for the momentum and velocity update equations. We also have the conservation of energy principle, which states that energy cannot be created or destroyed, only converted into different kinds of energy. At the bottom, we can see our equations for delta K, delta potential gravitational, and delta potential spring. And we can see that our energy is equal to the total of all these energies. The purpose of the lab is to see how the conservation of energy can be applied to a complex system. By using GlowScript, we are able to look at a simulation of how the energy principle will look under ideal conditions. From the GlowScript code, we are able to see that the model follows the conservation of energy principle. The energy versus time graph shows that the total energy of the system is 0 for the entire time that the spring is oscillating. This is a good model of what actually occurred in the lab, since the energy was also converted in the experiment. In defining the system, we said that the system is the block, the spring, and the earth, and the surroundings is everything else. At equilibrium, the net force is 0 because the spring force is equal to the gravitational force. However, once the spring is released, the net force will change since the spring force is non-constant. On the left, we can see the video from the tracker. In order to perform this experiment, we first needed to measure the length of the spring before and after the mass was attached, as well as weigh the mass. The guy in the video released the mass from a position of negative 0.12, negative 0.6250 meters. The spring then began oscillating while it traveled around in a circle, and we put the video into tracker to see, so we could plot the center of mass at each frame. The initial conditions include the mass of the ball being 0.402 kilograms, with the ball position being at negative 0.12 and negative 6.25, with the initial velocity being 0. We also have the force of gravity is 9.8, the spring constant is 6.83, and the relaxed length of the spring is 0.123 meters. In order to do the calculations, we say that F-grav is the vector of 0, negative mg0, and the force of the spring is the negative spring constant times S, which is the magnitude of the change in the ball position and spring position, times L hat, and then the force of the net force is equal to the sum of these two forces. We then use the velocity update equation and position update equation to update where the ball is, and we update the spring with the L hat and S. Then we solve for each of the energies with that way we can sum them up to find the total energy. So here we can see the energy graph from the system, and we can see that it's conserved throughout the experiment. So for the x versus time graph, we can see that the graphs are mostly the same, with the exception that the experimental data is only slightly lower than the model data. And for the y position, we can see that the experimental data varies greatly from the model data, and this could be caused by the fact that there are more forces acting in the y direction rather than the x direction. Sources of error could include having a non-ideal spring, which would cause that fluctuation in the oscillations, and then the video might have had slightly different numbers than the tracker, and then there could be other forces such as drag. So does this model follow the energy principle? And it does. From the change in energy graph, we can see that all of the energy is being converted between kinetic, gravitational potential, and spring potential, and this means that all of the energy is conserved since none of them are being lost as heat, and it's only turned into different kinds of energy. Then the period for the oscillations in the x direction is 1.615 seconds, and the period in the y direction is 1.519 seconds. From this, we can see that the period of x is slightly longer than the period of y. This means that it takes the block longer to complete a full rotation in the x than it does to complete a full oscillation in the y on the spring. In conclusion, we can see that our model follows the conservation of energy principle, since the energy is just being transformed into different kinds of energy rather than being lost as heat.